Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P3, Variant 1, October-November 2020. Let's get started. Sean is the manager of a museum. He buys a Chinese pot costing 1,200 yuan. The exchange rate is $1 equals 6.4 yuan. Work out the cost of this pot in dollars. First, we set up the currency conversion to find the equivalent of 1,200 yuan in dollars, which is what we are calling X. When we cross multiply and make X the subject, this is what we get, which is equal to $187.50. Sean records the maximum and minimum temperatures in degrees Celsius at the museum. Some of the results for 1 week are shown in the table. Find the difference between the maximum temperature and the minimum temperature on Wednesday. The maximum temperature on Wednesday was 15 degrees Celsius and the minimum temperature on the same day was -4 degrees Celsius. And so the difference is equal to 15 degrees Celsius minus -4 degrees Celsius, which is equal to 19 degrees Celsius. The minimum temperature on Saturday was 2 degrees Celsius higher than the minimum temperature on Monday. Find the minimum temperature on Saturday. The minimum temperature on Monday was -5 degrees Celsius. So to get the minimum temperature on Saturday, we simply add 2 degrees Celsius to -5 degrees Celsius. This gives us -3 degrees Celsius. In this week, the range of temperatures was 23 degrees Celsius. Find the minimum temperature on Sunday. The range, which has been given as 23 degrees Celsius, is equal to the highest temperature in the week, which was 15 degrees Celsius, minus the lowest temperature X, which was recorded on Sunday. When we make X the subject, we get X equals -8 degrees Celsius. These are the opening times for the museum. Work out the smallest number of guards needed each week. First, we need to find the total number of hours required to run the museum with 4 guards at all times. To get the number of hours from 9 o'clock to 17 o'clock, we subtract 9 o'clock from 17 o'clock, which gives us 8 hours. Monday to Friday make up 5 days. So the total number of hours the museum is open from Monday to Friday is equal to 5 times 8 hours, which is equal to 40 hours. To get the number of hours from 10 o'clock to 16 o'clock, we subtract 10 o'clock from 16 o'clock, which gives us 6 hours. Saturday and Sunday make up 2 days. So the total number of hours the museum is open from Saturday to Sunday is equal to 2 times 6 hours, which is equal to 12 hours. When we add 40 hours to 12 hours, we get 52 hours, which is the total number of hours the museum is open during the week. If 4 security guards are required at all times during open hours, then we multiply 52 hours by 4, which gives us 208 hours. So to get the number of guards needed each week, we divide 208 hours by the maximum number of hours a guard can work each week, which is 30 hours. When we type this into the calculator, this is what we get. This means the minimum number of guards needed each week is 7. The entry price to the museum is $18. This price is increased by 28%. Find the increased entry price. Since the new price is an increase of 28% on the old price, then we add 28% to 100%, giving us 128%. So we have 128% of $18, which is equal to $23.04. Gian has a first spinner in the shape of a regular hexagon. The spinner is numbered 2, 2, 3, 4, 4, 5. Gian spins the spinner. Find the probability that the spinner lands on an even number. This probability is equal to the number of sections on the spinner with an even number, which is 4, divided by the total number of sections on the spinner, which is 6. This simplifies to 2/3. Find the probability that the spinner lands on a number less than 6. This probability is equal to the number of sections on the spinner with a number less than 6, which is 6, divided by the total number of sections on the spinner, which is 6. 6/6 is 1. Find the probability that the spinner lands on the number 1. There is no section on the spinner with the number 1, so 0/6 is 0. Mai has two first square spinners, A and B. Spinner A is numbered 1, 2, 2, 4, and spinner B is numbered 3, 3, 4, 5. She spins both spinners and adds the two numbers. Complete the table to show all the possible outcomes. When we add 1 to 4, we get the number in this section to be 5. When we add 1 to 5, we get the number in this section to be 6. When we add 4 to 4, we get the number in this section to be 8. When we add 4 to 5, we get the number in this section to be 9. Use the table to write down the probability that the total is 5. This probability is equal to the number of outcomes that added up to 5, which is 5, divided by the total number of outcomes, which is 16. Use the table to write down the probability that the total is more than 5. This probability is equal to the number of outcomes that added up to be more than 5, which is 9, divided by the total number of outcomes, which is 16. Ning has a spinner numbered 1 to 6. She spins it 50 times and her results are shown in the table. Write down the mode. The mode is the number with the highest frequency. The highest frequency is 15. The number with this frequency is 1. Find the median. The median is the middle number. To get the position of the middle number, we apply the formula half n plus 1, where n in this case is 50. This gives us 25.5. This means the median is between the 25th and 26th numbers. From the table, to get the numbers in these positions, we start adding the frequencies from the lowest number. So 15 plus 12 is 27. This means the numbers in the 25th and 26th positions are both 2. So the median is 2 plus 2 divided by 2, which is 2. Work out the mean. The mean is equal to the sum of all the numbers, which is 1 times 15 plus 2 times 12 plus 3 times 9 plus 4 times 5 plus 5 times 2 plus 6 times 7 divided by 50. When we type this into the calculator, we get 2.76. From this list, write down a factor of 54. From the list, 18 is a factor of 54. This means 18 divides 54 completely with no remainder. From this list, write down a multiple of 19. From the list, 57 is a multiple of 19. 19 times 3 gives us 57. From this list, write down a prime number. From the list, 41 is a prime number. It has only two factors, 1 and itself. Write down the reciprocal of 64. The reciprocal of any number is 1 over the number. So the reciprocal of 64 is 1 over 64. Write 4.81 times 10 raised to the power negative 3 as an ordinary number. When we type 4.81 times 10 raised to the power negative 3 into the calculator, we get its ordinary form to be 0.00481. Write 75,000 in standard form. To write this number in standard form, we move the decimal point from the end of the number to a position after the first non-zero digit, which is 7. So we have 7.5. Since we moved the decimal point 4 units to the left, we multiply 7.5 by 10 raised to the power 4. Calculate 6.3 times 10 squared divided by 7 times 10 raised to the power negative 3. Write your answer in standard form. When we type this into the calculator, we get 90,000. To write 90,000 in standard form, we move the decimal point from the end of the number to a position after the first non-zero digit, which is 9. So we have 9.0. Since we moved the decimal point 4 units to the left, we multiply 9.0 by 10 raised to the power 4. The universal set E is a set of numbers containing 2, 4, 8, 16, 32, 64. Set A is a set of square numbers. Set B is a set of cube numbers. Use this information to complete the Venn diagram. First, we need to list the elements of A and B. From these lists, we see that 64 is common to sets A and B, so we put 64 in this region. After taking out 64 from set A, the remaining elements are 4 and 16. And after taking 64 from set B, the remaining element is 8. After filling out the elements in sets A and B, we see that the remaining elements in the universal set that are neither in sets A or B are 2 and 32. On this Venn diagram, shade the region P union Q. On the Venn diagram, this region has been shaded. Simplify 6a minus 3b plus 2a minus 4b. When we group like terms, 6a plus 2a is 8a, minus 3b minus 4b is minus 7b. Expand 5 times x minus 3. When we expand the brackets, 5 multiplies each element in the brackets, so 5 times x is 5x. 5 times negative 3 is negative 15. Solve these equations. X over 3 equals 18. When we multiply both sides of the equation by 3, we get x equals 54. 5x plus 18 equals 8. When we subtract 18 from both sides, we have 5x equals negative 10. And when we divide both sides by 5, we get x equals negative 2. 12x minus 3 equals 4x plus 21. When we group like terms, this is what we have. 12x minus 4x is 8x. 21 plus 3 is 24. When we divide both sides by 8, we get x equals 3. 6 raised to the power 10 times 6 raised to the power x equals 6 squared. Find the value of x. Since these two terms have the same base and they are multiplying, their powers add. So we have 6 raised to the power 10 plus x, which is equal to 6 squared. Since the bases are equal on both sides, then their powers must also be equal. So we have 10 plus x equals 2. When we subtract 10 from both sides, we get x equals negative 8. The Fraser family and the Singh family go to the cinema. Find the price of an adult ticket and the price of a child ticket. Let's represent the price of an adult ticket with A and the price of a child ticket with C. We are told the Fraser family buys 6 adult tickets and 2 child tickets for $124. This means 6A plus 2C equals 124. We are also told the Singh family buys 3 adult tickets and 5 child tickets for $100. This means 3A plus 5C equals 100. Now we can solve these two simultaneous equations to find the values of A and C. We'll be using the elimination method. We want to eliminate C, so we multiply equation 1 by 5. This gives us 30A plus 10C equals 620, which we've labeled as equation 3. Then we also multiply equation 2 by 2. This gives us 6A plus 10C equals 200, which we've labeled as equation 4. Now that we have 10C in equations 3 and 4, we can eliminate C by subtracting equation 4 from equation 3. This gives us 24A equals 420. When we divide both sides by 24, we get A equals 17.5. Now we can plug in the value of A into any of the equations to find the value of C. If we pick equation 2, we have 3 times 17.5 plus 5c equals 100. 3 times 17.5 is 52.5. When we subtract 52.5 from both sides, this is what we have. When we divide both sides by 5, we get c equals 9.5. Write 120,020 in figures. Here is the number written in figures. To confirm this, you can type 120,000 plus 20 into your calculator. Find the value of square root of 3,481. When we type this into the calculator, we get 59. Write down the fraction of the rectangle that is shaded. This is equal to the number of boxes of the rectangle that is shaded, which is 5, divided by the total number of boxes, which is 8. Find the percentage of the rectangle that is not shaded. To get this percentage, we divide the number of boxes of the rectangle that is not shaded, which is 3, by the total number of boxes, which is 8, and multiply by 100%. This gives us 37.5%. Write these numbers in order, starting with the smallest. To be able to compare the numbers, we convert them to a percentage by multiplying each number by 100%. The smallest percentage is 24.14%, which is 7 over 29, followed by 26.8%, which is 0.268, followed by 27%, followed by 29.41%, which is 5 over 17. Write 0.3728 correct to one decimal place. The first number after the decimal point is 3. The number after 3, which is 7, is greater than 5. So we add 1 to 3, giving us 4. The numbers after 3 become 0. Since these zeros come after the decimal point, they are insignificant. So we have 0.4 rounded to one decimal place. Write down the value of 19 raised to the power 0. Any number raised to the power 0 is 1. So 19 raised to the power 0 is 1. The height h meters of a tower is 128 meters, correct to the nearest meter. Complete the statement about the value of h. To correct the height h to the nearest meter, we have 128 meters. Then we bring in plus and minus 1 meter. Then we divide 1 meter by 2. The lower bound of h is 128 minus 1 over 2 meters, which is equal to 127.5 meters. And the upper bound of h is 128 plus 1 over 2 meters, which is equal to 128.5 meters. So we have h is greater than and equal to 127.5 and less than 128.5. Find the highest common factor of 126 and 180. First, we write 126 and 180 as a product of their prime factors. The common prime factors in these lists are 2, 3, and 3. So the highest common factor of the numbers is equal to 2 times 3 times 3, which is equal to 18. Write down an irrational number with a value between 6 and 7. An irrational number is a number that cannot be expressed as a fraction. We need to do some trial and error with radical numbers to come up with this. In this case, we went with square root of 43, which has a value between 6 and 7. The diagram shows a right-angled triangular prism. On the 1 cm square grid, complete the net of the prism. One face has been drawn for you. First, let's find the hypotenuse of the right-angled triangle, which is the width of the rectangle at the top. To get the hypotenuse, which we are calling y, we apply the Pythagoras theorem. This gives us y squared equals 3 squared plus 4 squared. When we make y the subject, this is what we get, which is equal to 5. On the grid, the base of the cuboid with dimensions 6 cm by 4 cm has been drawn for us. The base would be connected to the triangles on its sides. At the top, the base would be connected to the rectangle with dimensions 6 cm by 3 cm, and at the bottom, it will be connected to the rectangle at the top of the prism, which has dimensions 6 cm by 5 cm. Work out the surface area of the prism. The surface area of the prism is equal to the area of the two triangles, which is 2 times half of 4 times 3 cm squared, plus the sum of the areas of the other 3 rectangles, which is 6 times 4 cm squared, plus 6 times 5 cm squared, plus 6 times 3 cm squared. When we type this into the calculator, we get 84 cm squared. Work out the volume of the prism. Here is the formula for the volume of a prism. In this case, the cross-sectional area of the prism is in the shape of a triangle. We can find the area of the triangle using half base times height, where the base is 4 cm and the height is 3 cm. We've been given the length of the prism to be 6 cm. When we type this into the calculator, we get 36 cm cubed. The diagram shows an isosceles triangle and a straight line. Work out the value of W. The sum of the angles on a straight line add up to 180 degrees. So to get this angle, we subtract 118 degrees from 180 degrees, which gives us 62 degrees. Base angles in an isosceles triangle are equal. The sum of the angles in the triangle must add up to 180 degrees. So we have W plus 62 equals 180. When we make W the subject, we get W equals 56 degrees. ABCD is a rectangle. AE is parallel to DBF. Find the value of X and the value of Y. These two are alternate angles. Alternate angles are equal, so X equals 31. These two are also alternate angles, so Y is equal to 90 degrees plus 31 degrees, which is equal to 121 degrees. A, B, and C are points on a circle. AC is the diameter of the circle. Find the value of A. An angle formed in a semicircle is 90 degrees. The sum of the angles in triangle ABC must add up to 180 degrees. So we have A plus 53 plus 90 equals 180. When we make A the subject, we get A equals 37. Two regular octagons and a square meet at point P. Show by calculation that the three interior angles at P add up to 360 degrees. First, let's find the value of alpha, which is the interior angle of the octagon. The formula for finding the size of an interior angle of a regular polygon is 180 degrees times n minus 2 over n. The octagon has 8 sides, so n is 8. This gives us 135 degrees. The interior angle of a square is 90 degrees. So when we sum up all the angles at P, we have 135 degrees plus 135 degrees plus 90 degrees, which is equal to 360 degrees. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangle A and its image, triangle B, we can tell straight away that this is a rotation 90 degrees in the anti-clockwise direction. So now we need to identify the center of rotation. For this rotation, we see that point C remains fixed after the rotation. So that is the center of rotation. Point C has coordinates 2, -2. And so the full description for the transformation is rotation 90 degrees anticlockwise about the center 2, -2. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangle A and its image, triangle C, we can tell straight away that this is a translation because both triangles have exactly the same size and orientation. The only difference is they are located on different parts of the grid. Now all we need to do is to find the translation vector. From the illustration, we see that we need to move each vertex on triangle A 4 units to the left and 3 units upwards to get to triangle C. This means the translation vector is -4, 3. And so the full description for the transformation would be translation by the vector -4, 3. Describe fully the single transformation that maps triangle A onto triangle D. When we look at triangles A and D, we can tell straight away that this is an enlargement by a scale factor of 2 because each of the sides of the image, which is triangle D, is twice its corresponding sides in triangle A. This is a positive scale factor because the two triangles have the same orientation. From here, all we need to do now is to find the center of enlargement. We can get this by connecting at least 2 corresponding points on both triangles. The intersection point of the lines is the center of enlargement. In this case, we get the center to be -2, -5. And so the full description for this transformation would be enlargement by a scale factor of 2 about the center -2, -5. On the grid, draw the image of triangle A after a reflection in the line x equals -2. So first, we draw the line of reflection, which is x equals -2. Then from here, we need to reflect the vertices of triangle A in the line x equals -2. So for point B on the triangle, since we move 1 unit to the left to touch the line of reflection, we also need to move 1 unit to the left from the line of reflection to pin the new position of point B. We need to repeat the same process for the rest of the points on the triangle as well. When we are done, we are able to map out the reflected image of triangle A. Complete the table of values for y equals 15/x. When we plug in x equals -5 into the equation, we get y equals -3. For x equals -3, we get y equals -5. For x equals -2, we get y equals -7.5. For x equals 2, we get y equals 7.5. For x equals 3, we get y equals 5. And for x equals 5, we get y equals 3. On the grid, draw the graph of y equals 15/x. For x is greater than and equal to -5 and less than and equal to -1, and x is greater than and equal to 1 and less than and equal to 5. On the grid, we plot all the points in the table and connect the points with a smooth line. On the grid, draw the line y equals 6. On the grid, we've drawn the line y equals 6, which is simply a horizontal line passing through 6 on the y-axis. Use your graph to solve 15/x equals 6. In other words, we are to find the x-coordinates of the intersection point between the graph of y equals 15 over x and the line y equals 6. On the grid, we see that the x-coordinate of this point is 2.5. These are the first 4 terms of a sequence. Write down the next term. To get the next term, we simply add 7 to 29. This gives us 36. Write down the term-to-term rule for continuing this sequence. The rule is add 7. Find an expression for the nth term. Since the terms in the sequence have a constant difference between them, we can use this formula to get the nth term for the sequence. A1, which is the first term, is 8. D, which is the common difference, is 7. When we expand the brackets, 7 times n is 7n. 7 times -1 is -7. When we group like terms, 8 minus 7 is 1, so we have 7n plus 1. Find the next term in each of these sequences. For this sequence, we see that the difference between the terms are increasing by a constant difference of 2. So to get the next term, we add 11 to 42, which gives us 53. For this sequence, we see that to get the next term in the differences, we multiply the previous by 2. So to get the next term, we add 32 to 48, which gives us 80. Find the first 3 terms of the sequence with nth term, n squared plus 5n. To get the first term, we plug in n equals 1 into the nth term. This gives us 1 squared plus 5 times 1, which is equal to 6. For the second term, we have 2 squared plus 5 times 2, which is equal to 14. And for the third term, we have 3 squared plus 5 times 3, which is equal to 24. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.